Yeah, yeah, good evening all. So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not? Yes.
Yeah.
Thank you. Yes. So myself, I'm Vijay. Like I hold 20 plus years of experience in different technologies. So what experience in big data, Hadoop, Spark, Spark with Python and Scala, in this data engineering like data factory, data bricks, right? So as part of this, I'll be discussing what is Apache Spark, why PySpark, need for PySpark, and PySpark with Python and Scala, PySpark features, a real life usage of PySpark, and PySpark job market. The evolution of Spark. Spark was developed by Matai Zaharia in AMP Lab, Berkeley in the year 2009. Spark was introduced in the year 2009. Spark was open sourced in the year 2010. Spark was open sourced in the year 2010. Spark was donated to Apache Software Foundation. It was donated to Apache Software Foundation in the year 2013. Yes. If I define Spark in 5 lines. Spark is a open source distributed cluster computing framework. It's a distributed cluster computing framework, right, with in-memory computation features. The main thing what we see in Spark, in-memory computation, storage and processing both happening within the memory level in parallel processor style for large scale data processing. It's an open source distributed cluster computing framework with in-memory computation feature in parallel process style for large scale data processing. You can see all these features in big data Hadoop also, right? But you won't see this in-memory computation feature in case of Hadoop. Means here Spark has got a very high speed because of this in-memory computation, storage and processing both happening within the memory level, RAM level. That's why we see very high speed here, right? Yes. It's a very high speed processing execution model which can process huge data at a very high rate of speed. So it is a general engine for big data analysis, for processing, for computation, right? And why PySpark? Why PySpark, right? Yes, PySpark is the Python API to use a Spark. So it's PySpark is an API given by Python, right? It's a Python API to use a Spark. It is it is one of the lightning fast technology that is designed for fast computation. It is one of the demanding tool among the data engineers to work with bigger data sets, and the PySpark mainly used for. See, this Spark data is divided into multiple partition because you see huge data, GBs or TBs of data, right? That data will be divided into smaller partitions, stored across multiple systems and processed parallelly, right? Yes. Just a second, right? PySpark is used for running distributed SQL for creating data pipelines. Data pipelines. So PySpark is a data flow language. The output of one will be the input to the next flow, and the output of that will be the input to the next, right? Ingesting data into databases, running ML algorithms, and working with graphs or data streams. Working with graphs or data streams. So PySpark used for running distributed SQL for data pipelines, ingesting data into databases, running ML algorithms, and working with the graphs or data streams. need for PySpark, right? You see, like huge data is getting generated, right? Through online or offline. We see the data contains some hidden patterns, some unknown corrections, some market trends, some customer preferences, right? We need to extract some valuable information or data from that raw data. So we require some efficient tools. We require some efficient tools to perform this type of operations on this big data, that is huge data. So that is, so we need to have some scalable and flexible tools to crack this huge data. PySpark is such a kind. So combining Python and Spark will be the very efficient for the world of big data. That's why Apache Spark community, they came up with a tool called PySpark. That is Python API. That is Python API for using Spark. So generally, yes, Spark can be implemented in multi-languages. Spark can be implemented with multiple languages, but mostly preferred languages are Python and Scala. Python and Scala, right? But if you see the difference between this Python and Scala languages, right? Mm. Python is interpreted language and dynamic typed. Dynamic typed means, right, no need to, so if you're saying x has 10, a integer variable created here. If you say 4.5, a float variable creates dynamically. You say hello, right, a string variable based upon what value you are assigning. Based on the value assigned, the variable gets created dynamically. That's why we say dynamic typed, but the Scala is statically typed. So Python has a huge community. It has got a huge community. Scala community is smaller. Python has got thousands of modules, 89,300 inbuilt modules for supporting different environments. Scala has got no such modules. Python contains powerful libraries for data science, ML, for graph algorithms, and for streaming, right? But Spark is by default built using Scala language. Previously, Scala was used a lot, but in the current industry, right, Spark with Python is used, right? Because Python has got many modules. So Python implementations. See, if you see the features of PySpark, if you see the main features of PySpark, right? Yes. One second. The main features of the PySpark. One is in-memory computation. Generally, in the case of big data, Hadoop, if it see in that data stored in the disk and is processed, but here everything in-memory computation, right? Yes. So the data will be stored within the memory level and processed within the memory level. That is the main feature of Spark, in-memory computation. And secondly, parallel processing. So the data is divided, right? This data is divided or distributed across multiple systems and are processed parallelly. It is lazy evaluated. Spark is what? Lazy evaluated. Lazy evolution and active evolution. Which one is better means a lazy evolution. Whenever you require, you will execute the entire data flow. Immediately, whenever you define, it is getting executed means it is active evolution. Lazy evolution, on demand, you execute by performing some action. So you have defined some data flow. That data flow should be executed on demand. That is what lazy evaluated. Immediately defining, immediately executing, that is active evolution. But once you define, but later I will just perform an action to execute it. That is lazy evaluated. Just like in programming languages, functions, right? You will define it, but you will call it. Until you call it, won't execute. Here also, the data flow, until you make some action, they won't get executed. That is what lazy evaluated. And it has got immutable nature. Immutable means, see, Spark data objects, what we say is they're immutable. Changes, modifications not allowed to the original data. But from that data, you can generate new objects, but the original data is immutable, right? And main thing is partitioning. If data is Partitioning, right? Yes, if data is partitioned only, then you can see that distributed and parallel processing, partitioning. And also one more important feature of Spark, like powerful, it has got powerful fault tolerant, right? It has got powerful fault tolerant model. And one more feature, persistence, right? Already executed transformation output. If you want to reuse, you can reuse. That is what persistence. Already executed output, already executed transformation output. If you want to reuse, instead of re-executing, we will reuse the already executed transformation output. So these are the main, right? Parallel processing, in-memory computation, partitioning, fault tolerant, and persistence. Just the same thing as specified here. In-memory, lazy evaluated, partitioning, immutability. Yes. Real life usage of PySpark. So if you see, it is used mostly in the commercial sector, like Spark real-time processing, like bank and other financial, right, fields. They are using Apache Spark for retrieving the customer social media profile and analyzing and gaining useful insights which can help to make the right decision. Credit risk assessments, target ads, customer segmentation. So Spark plays a vital role in fraud detection and also in healthcare in predicting the patient who is going to face that issue even after being discharged from the clinic, right? And entertainment industry like Netflix using Apache Spark for real-time processing and for personalized online movies and for web series. It is going to process around 450 billion events per day over the server side applications. Even for trade and e-commerce, the popular e-commerce websites like Flipkart, Amazon, all these they use Apache Spark for advertising, for enhancing the customer experience, and for optimizing overall performance. Even for tourism industry to provide advices to millions of customers, right, from comparing different websites. Motivation towards the Spark, right? Yes, motivation towards the Spark. If you see, yeah, Yahoo has taken a table of 100 TB sites of 1024 columns. Yahoo, the task was sorting based on 16 columns. It's not in a single column, sorting based on 16 columns. The time taken by Oracle around the 3.5 days it has taken. MySQL has taken around 6 days. Teradata, a specialized database used for data warehouse, it has just taken 4.5 hours. Netija, that's just taken 3 hours, right? Hadoop has taken 3.4 minutes. Spark. So, so here, if these have taken days of time, these have taken hours of time. Hadoop has just taken minutes of time, right? Hadoop has taken just minutes of time. Even though, see here, Hadoop has got very high speed, where these have days, these are hours, but it has taken minutes of time. But comparing Hadoop and Spark, Spark is 100 times faster than Hadoop. Then see, what would be the speed of Spark? That's why Spark is very much preferred today. The rate at which the events are generated, at the same rate of speed, the Spark can process and Spark can execute those events. That's why at one side, when the events are getting generated, at the other side, we need to have a processing technology which can process at the same, means, for example, for example, in 1 second, if 10 lakh events are getting generated, but if they are getting captured and they're getting processed in 1 hour, by the time 1 hour, right, so millions of events will be generated. So, but I want a technology, I want a processing model in which at the same rate of speed it is going to process that. So even for streaming kind of things, right? So at at one end, if they are getting captured, at the other end, the events are getting processed simultaneously. So that is what Spark, which has got high speed. I said Spark can be coded with multiple languages. Multi-language support, I said, right? Yes, with Python, Scala, Java, and R language. Spark was default written in Scala language. It was default written in Scala language. But Scala is the native language of Spark. If you are comparing Spark with other technologies, right? Yes, Spark and Tej and Spark. Tej, previously we have got Tej, both follows DAG. Both are going to follow DAG, directed acyclic graph model. But Tej doesn't support in-memory computation. Spark has got in-memory computation, so Spark has got very high speed as compared with Tej. If you see other in-memory computation systems, right? Not only Spark, we have got some other in-memory computation systems like HANA. But if we discuss the difference between HANA and Spark, both follows in-memory computation. But HANA is not distributed, but Spark is distributed. HANA is not distributed, but Spark is distributed. Spark is mainly designed for batch applications. What do you mean by batch applications? We have got two types of applications, online applications and batch applications. Online applications means request response. Whenever you give request, you need to give response. Request response or client server. But batch applications are not like request response or client server kind of thing. Online applications, we have got two types of applications, I said, online and batch. Online means user interactive. User gives the input, user gives the request, gets the response. But it's not like request response. Batch applications, batch, the name itself saying batch, millions and trillions of records are involved. User non-interactive applications, and Spark is mainly designed for iterative algorithms. It is mainly designed for iterative algorithms, interactive queries, for the SQL queries and for streaming. And if you talk about Hadoop and Spark, in Hadoop, we have got an execution model called MapReduce. Hadoop and Spark, MapReduce drawbacks of transformations cannot be reused. Transformations cannot be reused means, right? Already, if you have executed a transformation, the output, if you want to reuse, you cannot. You cannot. But in case of Spark, the already executed transformation output, you can reuse. Bad for iterative algorithms. MapReduce, bad for iterative algorithms. Not a flexible parallel process. MapReduce is not a flexible. See, bad for iterative algorithms means if we talk most of the ML algorithms are iterative algorithms. You should keep on applying until the error becoming zero. So, but MapReduce is bad for that. But that is that too. It's not a flexible parallel process. MapReduce, mapper phase, reducer phase. You'll be having two phases until mapper phase execution is done. Reducer phase cannot start that. First mapper has to execute, next comes reducer. Slow processing, just now I said, right? MapReduce. Spark is 100 times faster. Spark is 100 times faster. And there is a Apache Pig, Apache Spark compared with Apache Pig. Pig is also Apache product. Spark is also Apache product. Both are data flow languages. But Apache Pig, it's one of the best scripting language. If you see Apache Pig, for example, if you have written a code in Java with 100 lines, the same thing you can implement in Pig Latin language. We say Pig Latin language. It was a simple scripting language, very simple. 100 lines of Java code you can write within 7 to 8 lines. That is what the simplicity of Apache Pig. But in Pig, The entire data flow is again converted into MapReduce. The entire data flow is again converted into MapReduce and executed. See, for big data, for data engineering, right? Yes, Sai Krishna, right? For data engineering, if you take any data, if you go for data engineering, right, always the processing execution model used is Spark only. Even now, right? It was introduced, I said, in 2009, but implementation started from 2016, 17. But now mostly used, previously they used to use Spark with Scala implementation. Now Python implementation mostly used. So here the drawback of Apache Pig is the entire data flow is converted into one MapReduce job. But again, MapReduce is bad, I said, right? Yes. And Apache Spark and Apache Flink, this immediately in 2016, 17, those days, right? Immediately after Apache Spark got introduced, Flink was introduced. Apache Flink was introduced by same Apache. Then people started, right, thinking that Flink is dominating and Spark. Flink is dominating the Spark. Yes, it was true. Flink was dominating Spark at the time. People who already got updated, who are just doing with Spark, they started updating with Flink. But both are Apache products only. Their purpose and objective are same. But in the earlier version of Spark, the earlier versions of Spark, Spark was weaker in machine learning, but the heart of data analytics is machine learning. But slowly, like Spark introduced powerful libraries for machine learning, for streaming, and for graphs, right? Before Spark 1.6, Spark was weaker as compared to Flink, but from Spark 1.6 onwards, Spark equal to Flink, but from Spark 2.0, from Spark 2 onwards, Spark is totally dominated Flink. That's why you won't see that. Yes. Okay, that is Apache Spark and Flink. So if you see the Spark features, if you see the Spark features, in-memory computation feature, which you are not able to see in Tej, distributed execution, which you are not able to see in HANA, good for iterative algorithms. Transformations can be reused, which you cannot see in MapReduce. Flexible parallel process, which you cannot see in MapReduce. Very high speed as compared to MapReduce. Supports advanced analytics. It has got multi-language support. Parallel processing, right? Yes. And lazy evaluated. Okay, that is what comparison of Spark with other things, right? So initially we got RDDs, right? Resilient distributed data sets, right? Resilient distributed data sets. Resilient distributed data sets, we say as RDD. Yes. What we say like Spark data objects. Spark data objects are called as RTDs. But now data, okay, RTDs, you need to have some knowledge, but for having knowledge for this data frames, we'll be having Spark data frames. But before that, you need to know something about what RTDs, Spark data objects are called as RTDs. These RTDs are subdivided into partitions. RTDs are subdivided into partitions. These partitions are distributed across multiple RAMs. multiple slave nodes. These partitions are distributed across multiple RAMs across multiple slave nodes. RTD programming style. RDD programming style, right? Is a data flow. Programming style is data flow. Data flow is what? Data flow is a sequence collection of pipes. It is a sequence collection of pipes. At each pipe, what is a pipe? A pipe is a data operation. A pipe is a data operation like such as loading, such as loading the data, transforming the data, filtering the data, grouping the data, merging the data, etc. In Spark, in Spark, data flow is executed in sequence. It is executed in sequence, that is RTD by RTD. That is RTD by RTD. One after the another, one after the another, with in-memory computation feature, with in-memory computation, with in-memory computation feature and persistence feature. RTD sequence, it is executed in sequence RTD by RTD, one after the other, because the output of one will be the input to the next, right? So two cannot execute in parallel. In Spark, two RTDs cannot execute in parallel. But if a RTD has 30 partitions, then all the 30 partitions. In Spark, two RTDs cannot execute in parallel, but if a RTD has 30 partitions, then all the 30 partitions are executed parallelly. Generally, observe here, right? RTD, RTD1, how it is created, how RTD1 is created. You have got a file, huge data file, the GBs or TBs of file. Using a Spark context, if you are loading, yes, Spark context dot text file, the file path. Using Spark context text file, right? If you are loading, then RTD1 is created. On this RTD1, if I perform some map functionality for for all the employees, just add 5,000 as the sal. Add 5,000 as bonus to the salaries of each employee. RTD2 is created. RTD from R1.map. Whatever the result you get, that is also a RTD. On this R2, I'll just perform filter. R3 is generated. In R2, for example, 10 lakh records are there. In R3, filter only city Hyderabad. There, if it's in the filter, you will say filter condition. You see only 1 lakh employees available, right? In city Hyderabad. Again, on R3 dot group by operation, R4 is generated. R4 dot, again, some mapping functionality. R5. Finally, say R5 dot collect. You are collecting that R5 output. Resultant RES. Understand here? Yes. If you perform any transformation or filter on this RTD, the result is also RTD. Where these RTDs are getting stored, everyone try to respond. I want the sessions to be interactive, right? Everyone unmute yourself and try to keep responding. Yes, Spark data objects you got. First R1 was there, slowly R2, R3, R4, R5 got generated. From that data only, right? Yes. Where these are stored, assume that RTD1 size is around 2 TB or 2 TB. Where these are stored, where this R1, R2, R3, R4, R5, where these are stored R1, R2, R3, R4, R5. See, in Spark, single master, multiple slaves. Single master, multiple slaves. System 1, system 2, system 3. Where these RTDs are stored means they are not stored. See, if for example, if R1 size is only 2 TB, where it is going to accommodate the entire RAM, means whenever this R1 loaded, the entire RAM got filled. The entire RAM got filled. Then there won't be any space for the upcoming RTD R2 to get loaded. Yes. Where this R2, R3, R4, R5 will be loaded then. And that too, if all these RTDs are getting loaded into the RAM, then totally the RAM, everything will be filled. If there are any RTDs up for the upcoming things, you don't see any space for the upcoming RTDs to get loaded. So here, observe carefully how this computation is going to happen. From R1, R2, the output of this as input to this. So R2 output as input to this. R3 output as input. R4 input to R5. Just you want to get the result of this R5. Just you want to get the output of this R5. See, when R1, its partition, R1 divided into partitions, the partitions will be loaded into RAM and will be processed. The processed output will be collected by R2. See, R1 output is taken by R2. When now R2 gets loaded, computed. Once R2, its partitions, everything gets loaded and processed. Then R1 and its partition gets removed from the RAM. R1 and its partitions, everything gets removed from the RAM. When R2, what all the partitions are loaded into RAM, they are processed parallelly and the output is given to R3. Now, whenever R3 is loaded and computed, R2 gets removed from the RAM. Whenever the next one is ready and computed, the previous and its partition, everything gets removed. Finally, when R5 is ready, R4 gets removed and its partition, everything. Once R5 output is collected by the client, this also got removed. Now, how many RTDs in the RAM? Yes. RTD by RTD, it loaded. How many partitions? Once the next RTD is ready, the previous one gets removed. Once the total execution is completed, no RTD in the RAM, right? No RTD in the RAM. Yes. You can trigger the next flow. In the next flow also, one by one RTD will be executed. But don't think all the RTDs will be gets loaded at a time. They get processed. That much of space, RAM space won't be available. Right? Just observe this flow once again. Let's check with this. R1 is there. From this R1, R2, R3, R4, R5, R6, R7, R8, R9. This is flow. How many flows? Three flows are there. This is flow 1. This is flow 1. This is flow 2. This is flow 3. Flow 1, flow 2, flow 3. Observe this flow 1, right? R1, R2, R3, R4, R7. Flow 2, R3, R5, R8. Flow 3, R9, right? Yes. Yes. Fault tolerance mechanism I'll discuss, right? Sai Krishna with R4. So these three flows are there. These three flows are there. Flow 1 if you want to execute. R1 is there, R2 is there, R3 is there, R4 is there, R7 is there. Understand here one query was asked. Okay, first let R1 loads, R2 loads and computes, R2 loads and computes. Once it is loads and computed, R1 gets removed. When R3 loads and computes, R2 get removed from the RAM. Now some query was asked. While R4 has taken that input from R3 while computing, suddenly R4 submission is down. Then there is a data loss and there is a task failure, right? Still until this R4 computation is finished, R3 not removed from the RAM. So if any system is down here or anything is down, it will take again the input from R3 and it loads. It takes and again reloads that input to other systems which other than the one which is down. It takes that. Why? Because still R3 not removed, it can take that input and computes this R4. Once R4 is ready, R3 gets removed. Once R7 is ready, R4 gets removed. Once the total output is collected by the client, this R7 also deleted. No RTD in the RAM. No RTD in the RAM. Now if we execute flow 2, if we execute flow 2, in the flow 2 you see R1, R2, R3, R1, R2, R3, R5 and R8. When this is ready, this gets removed from the bus. When this is, see, resilient distributed data sets. Once this is loaded and computed, this gets removed from the RAM. In this way, the let's previous one gets removed from the RAM. When this output is collected, the final RTD is also gets removed. No RTD in the RAM. So flow 3 also in the same manner, right? Flow 3 also in the same manner. Yes. R1, R2, R3, R6, R9. When the second one is ready, this gets removed from the RAM. When this is ready, this gets removed from the RAM. When this gets ready, this gets removed from the RAM. When this is ready and computed, this get removed. Final output is collected. This also gets removed. No RTD in the RAM. The next you can trigger the next flows. But here, what is the drawback you observe, right? You're executing the flow executions. But R1, R2, R3, R1, R2, R3, R1, R2, R3, this is common among all the three flows. But every time you are re-executing this first three. Every time you are, for example, it is a very big flow. 70 statements are there. R40. Here R3 output is used by R4, R5, R6. So here always the first three steps are re-executed again and again. In such case, identify that RTD. Identify the RTD whose output is given to multiple flows and persist it. Persist it. How will you persist? R3 dot persist. Persist is means even though the next one is ready, the previous one doesn't be removed from that. Observe this, right? If it is persisted, right? This is your diagram R1, R2, R3. R7, R8, R9. This is persisted. This is persist, we say R3 dot persist. So now execute the flow 1. Execute the flow 1. R1, R2, R3, R4, R5, R7. When this is loaded, second one R2 gets loaded and computed, R1 gets removed. R3 is a persisted one. When it is ready, the previous one gets removed from the RAM. Right. But R3 is persisted. When R4 is ready, R3 won't be removed. It cannot be removed from the RAM because it is persisted. Even though the next one is ready, the previous one won't be removed. Once R7 is ready, this gets removed. What is present in the RAM? R3 is present in the RAM. Now execute the flow 2 onwards. Flow 2 onwards. Yes. If you want flow to R8 dot action. It checks R8 input is R5 not available in the RAM. R5 input is R3. R3 available in the RAM. So the flow is R3, R6, R8. That's it. No need to, for example, the 50th RTD output is used by multiple flows. The first 50 steps no need to execute for the second flow because R3 is persisted and it is ready to provide you the output. R3 is ready to provide you the output. So yes, when R3, so the flow is R3, R6, R8. Yes, when R6 is ready, R3 won't be removed. When R8 is ready, this gets removed. When the output is collected, this also gets removed. So R3 in RAM. Flow 3 also no need to re-execute from the beginning, can execute from this. So here, whenever you want to execute R9 dot action, if you say, then the entire this flow is going to be executed from its root. R9 dot action means from R9 output will be collected. If we say R6 dot action, R6 output will be collected. So here also R9 input R6. R6 input is R3. R6 input is R3. The flow is R3, R6, R9. When R6 is ready, this gets removed from the RAM. When this gets removed, once the output is, sorry, this R3 won't be removed, right? This persisted. And once the output is collected, this also gets removed. So in all the three cases, R3 is available in the RAM. R3 is available in the RAM. Means for the other flows, right? If you, once your execution completed, now you see that it is not required R3 dot unpersist forcefully. R3 dot unpersist. R3 dot unpersist. R3 dot unpersist. Immediately it will be unpersisted. Whenever the session is closed, it will be unpersist. When the server shutdowns also, it will be unpersist. All right. So this is what persisting is one more important feature of an RTD. You can see this course content, what I'll be discussing, right, in brief about this. Right, 1 second. You can just check with this course content. PySpark in brief with many working examples. Check with this. Check with this one. What is Apache Spark? Why PySpark? Need for PySpark. Spark, Python and Scala and PySpark usage, PySpark session, Spark context, PySpark RTD, parallelizing, repartitioning, broadcast variables in accumulators, PySpark RTD computation. What is an RTD? RTD actions and transformations, computations, RTD persistence, persistence options, memory only, disk only, memory and disk only. Spark core computations, fault tolerance mechanism, word count, creating Spark objects, groupings and aggregations, single grouping, multi-grouping, single aggregations, multiple aggregations. Right, difference between group by key, reduce by key, various inbuilt actions and transformations of PySpark. various inbuilt actions and transformations of PySpark, right? See, Sai Krishna, right? R3, whenever if a RTD is persisted, right? You should see R3, once your work is done, once your flows are executed, R3 dot unpersist, you need to unpersist it. Otherwise, whenever you stop the session, it will be unpersisted. Or whenever the server shutdowns, it will be unpersist. Generally, we use unpersist method to persist it. Unpersist happens immediately, but persist won't happen immediately. Why? Whenever you say persist, right, immediately it won't be persisted. But unpersist means immediately it will go and remove it immediately. Unpersist happens immediately. Because if you want to persist R50, if R1 is there, R2 is there, so on R50, so on R80. This one you want to persist means when it will be persisted, once R1, R2, R3 up to 49 RTDs, they should be loaded. Then when R50 is loaded, then it will be persisted. Until then, it won't persist. But unpersist is not like that. It will just go and whichever RTD is present, it will be unpersisted. Okay, so I was just discussing various different inbuilt actions and transformations by Spark SQL data frame, making a data structured, data frame API, various data frame API functions, creating empty data frame to pandas, struct type, struct field, row class, column class, select, collect with column, column renamed where, filter, drop, order by, group by, join, union all, union by name, UDF, user defined functions, map, flat map for each. Yes. Map, flat map for each sample, fill nulls, partition by Spark, SQL functions, aggregate functions, window functions, data and timestamp functions, JSON functions, right? PySpark built-in functions when expr lit split pancat substring translate overlay to timestamp, right? Yes. So these are all that various functions. PySpark external sources working with SQL statements, Spark and Hive integration, MySQL working with CSV, transformations and actions, narrow and wide transformations, adding of new columns, dropping columns, handling nulls, right? Yes. Deployment modes, local and cluster mode, right? Yes. By Spark applications, states and tasks, drivers and executors, building Spark applications, deploying Spark applications to cluster and tuning, performance tuning, PySpark and the streaming concepts and integration with Kafka and PySpark ML, right? Yes. PySpark ML. Okay. So you can see it in the chart, right? A message given by this online team that payment process, the course content, their contact details. Yes. So more on this RTD's computations, how they are powerful fault tolerance model. I need to discuss why, because the Spark data is running or distributed across multiple systems. There is a chance of the systems getting down. So how Spark is able to, how this is going to be resolved, right? How what Spark is providing. Spark has got powerful fault tolerance. So it can regenerate the lost partitions, right? It can regenerate that lost partitions. And something we need to follow some rules in the persistence. What are the rules? So before we go with the practical things, right? Yes. So offerings from my side, you will be getting each and every session video, right? Even if you're absent for You can go through the video and attend the next session for the better understanding. Soft copy of this class note, assignments and tasks to work. A WhatsApp group means a group WhatsApp group separately. So where you can, if you have got any errors, anything, right, you can take snap and post it in the group. Anybody can answer. I'll be on live interactive hands-on the sessions, whatever the practical sessions. If you want, you can do parallel along with me and interview questions, right? Yes. This is what Spark, which has got very high demand today. One of the fast and very high speed processing technology, right? So that too, even if you see the salary packages, even if you see the salary packages are too huge, right? Means if you see as compared with other technologies, it's 1.5 times more than other technologies. In the same way, they'll be expecting the skills, technical skills from you, right? You'll be getting the great command by this end of this course, right? So it goes around 8 to 10 weekends, right? We'll be discussing in brief. It goes to around 8 weekends. We'll be discussing in brief about this. So the prerequisite for this is basic Python, basic SQL, right? Any other queries, right? So next Saturday and Sunday, we'll be discussing more. We'll be starting with the actual things, actual parts, right? Any other queries, right? Anyone? So next Saturday, there will be so the link will be changing. You are supposed to get enrolled for getting the link to your mail. A new link you will be getting to your mail, right? Check that. You get enrolled for getting the notes, videos, and getting added to the WhatsApp. All the sessions will be interactive session. At any point, you can unmute and you can ask your query. And once we enter into the practical, you will be responding for each and every statement I type. All the sessions will be interactive, right? If someone was asking a query, right? Yes.
Just one question, the batch is like weekend batch.
It's a weekend batch, Saturday 2 hours, Sunday 2 hours it will be.
Okay, what will be the timing on each day, like Saturday and Sunday? Is it same timing?
Yes, 5:30 to 7:30, 5:30 to 7:30 it will be.
Okay.
Yes. From next week, we'll be having 2 hours on Saturdays, 2 hours on Sundays. Even sometimes I'll be taking some bigger sessions, like 2.5 hours I'll be taking, 2.5, 3 hours I'll be taking once we start with the practical part. Fine.
So to enroll, we need to make the payment, and from next week, from module one, you will be starting, right?
Yes.
Okay.
So, so don't forget, people get enrolled, but try to share the screenshot of your payment to that mail ID that is provided. But see here, most of you will just get enrolled, but you won't send the screenshot of your payment to that mail ID, DURGASOFT online training. They'll forward you the link for the next Saturday's class to your mail ID, right? So you'll be getting the videos to your Google Drive. Check your Google Drive. In that Google Drive, shared with me option will be there where you can see all the shared things, right? Where you can see that every day, every week, the videos will be updated, right, to your Google Drive. Notes I'll be forwarding, clear notes, what all we discussed, right? Everything I'll be forwarding these things, what we discussed today. So yes, this everything, Spark introduction. We'll be forwarding these notes and a WhatsApp, you'll be having a WhatsApp group where if anything directly you can have interaction with me. Any errors or anything, right? You can just post in that WhatsApp, right? Yeah, any other queries you got anywhere, right? So from the next week, we'll be starting with this RTD's computations, fault tolerance mechanism, and this will be entering into the practical part, right? Yes. Yes.
So from next week, like it is directly practical, or is
No,
it
no.
starting module one?
Some more discussion is there. So we will be continuing where we are stopped today.
Okay.
So steps to be followed in RTD computations. What are some of the actions and transformations examples? And fault tolerance mechanism if any system fails, different ways of creating RTDs before. So this all I'll be discussing before we go with the practicals. Next Saturday also I'll be discussing with more discussion on this RTDs computations. What are the persistence steps you need to follow? You have got some steps you need to follow, some rules you follow for persistence. What is fault tolerance? How this fault tolerance model in Spark, right? And persistence options are the memory only, disk only, memory and disk, these things. Okay. Okay, so fine. I'll sign off for now. Meet you next Saturday, same time at 5:30. Right. Check that. Get enrolled. You're for getting the videos and notes to your mail, right? Thank you all for your time. Thank you. Meet you next Saturday. Bye.